Now we're going to look at a past paper question. I think this one came from 2013. And what it says is, describe fully the locus of the points representing z if z plus 2i over z minus 2i is purely imaginary. Now the important thing to note here is if it's purely imaginary, the imaginary number could be anything, so there's no constraint. However, it means the real part is 0. So as with all loci questions, we'll start as we usually do, which is replacing z with x plus iy. So we end up with x plus iy plus 2i over x plus iy minus 2i. Then we're going to equate our real and our imaginary. Now, we can't split this into a real and imaginary. All the time we've got an imaginary number on the bottom. So to get rid of the imaginary part on the bottom, we're going to multiply by the complex conjugate of the bottom. So we multiply top and bottom by x minus iy minus 2. So the numerator here is going to be x squared minus I x y minus 2 plus I x y plus 2 minus I squared y minus 2 y plus 2. But remembering I squared is negative 1, so that becomes plus y minus 2 y plus 2. And the denominator is going to become x squared. The imaginary parts will disappear, apart from the minus y squared y minus 2 squared. But remembering minus y squared becomes plus 1, so that becomes plus y minus 2 squared. Now we're really only interested in the real bit, so we're going to take the real part of this number, which is x squared plus y minus 2 y plus 2 over x squared plus y minus 2 squared. And we know that the real part is equal to 0 because it's purely imaginary, which means there's no real part. If we bring the denominator up and multiply, that's going to become 0. So you end up with x squared plus y minus 2 y plus 2 equals 0. Let's expand out. X squared plus y squared minus 4 equals 0, which is x squared plus y squared equals 4. Now that is the equation of a circle. Center 0, 0, radius 2.